Good day to you all. Welcome to Danfo Academy. Today we'll be talking about Ampere's second law. It's the continuation from our previous class, which is force on a conductor in a magnetic field. So today we'll be talking about the Ampere's second law. Now, Ampere has already showed that if you have a continuous closed line or loop which is drawn around one or more current carrying conductor, the B there is the flux density in the direction of an element, the L of the loop. So this is actually the formula. As you can see here, B the L equals to U I. Now, as you can see, this sign is the integral taking completely around the closed loop, while the B, as we all know, the flux density change in L, as you can see, the length U, this is the free space, and we have the I, which is the total current enclosed by the loop. So now, this is the formula. When you are asked to provide Ampere's second law, you have to look into this formula in your exam text or assessment, anything. When you are asked about this Ampere's second law, you have to provide them with this. Now, this simply means that if you have a conductor like this, and let's say the currents are flowing upward like this, certainly you have a what? Magnetic field encircling it like this. Here is what we call loop. That is, as you can see, from here to here till the other end is what we call a loop. As you all know, that if the current is flowing upward, the magnetic field is certainly flowing like this. B, can you see? Flowing like this. Here is a B, it's flowing like this. So let's say L is the length of the what? The length of the what? Of the wire or the conductor. Now, simply you bring this formula like this, say somehow like this. B the L equals to UOI. So you integrate this. As I told you earlier, that this is the sign of integral, taking completely around the closed loop, and this will certainly be B integration of 2 pi O d L equals to UOI. What does this mean? That means we are integrating respect to what? Change in L. That's why this B is left outside, because all what matters to me here is to integrate this, the L. So looking into this, let's say the B, and talking about the integration, wherever you have on the top and down, it will take the form of what you are integrating. Now let's say we start with, let all this the L be 2 pi. So it's gonna be like this, B 2, you have your 2 pi here equals to U or I. Now don't forget the 0 too. We have to, if the L equals to 0, then it's gonna be like this, multiplying what? 0 equals to U I. When it multiplies this one equals to 0 equals to U I. Then you minus it from here. This will be B into, whenever you integrate, the sign of the integral will change. You write your 2 pi here. So now you minus this from this, minus 0 equals to what? UOI. So whenever you're integrating, if you have anything on the starting point here, the lower point here, it will take the form of what you are integrating, then you minus it from each other. That's what I did here. 2 pi minus 0 equals to what? UOI. So now we're talking about the length of the conductor, B equals to what? This is, sorry, this is R. Your R will be here, 2 pi R, because it's the length. It can be defined as the length of a conductor. L equals to what? 2 pi R. That's the formula. So now you have to use your 2 pi R minus 0 equals to what? This 2 pi R is multiplying this 2 pi minus 0 equals to UOI. So doing this, this will be what? B 2 pi R equals to UOI. Make this flux density the subject of formula. It will be 2 pi R. You divide this by there, so 2 pi R. As you can see here, B equals to UOI over 2 pi R. Now, this formula will be used whenever you're given your radius and they're talking about when they're talking about a loop around a conductor. You have to use this formula UOI over 2 pi R. Then in that question, you'll be given your R, you'll be given your permittivity of free space and the I. Now here is the place question. The play question says find the acceleration of an electron moving with a speed of 2 times 10 raised power 8 meter per second. That is, you already have your V. Your V to be, you have your V to be 2 times 10 raised to power 8 meter per second along a straight wire. So you have it as 0.025 meter, and you're given the value for Q, the M, the U. So you have to find the acceleration. That is, you have to find your A. So for you to first find your A, you have to go through F equals to B V Q, because we only know the value for M. We don't know the value for F because we're given in the question the value for M here. So now, looking into this, I have to first go through B F equals to BVQ. Now, I'm already given my B. Sorry, I have to find my B. So my B is what? B equals to UOI over 2 pi R, because it's an electron moving along a what? Straight wire carrying current. So now, your UO is 4 pi times 10 raised power minus 7. So then you multiply it by 3, which is the current. 2 times pi is 22. So I mean your pi is 3.142, because it's 22 divided by 7, which gives you 3.142, multiplied by you're given your radius to be 0.025 meter. So when you do all this, it gives you 2.4 times 10 raised power minus 5 C. Don't forget the Tesla. You have the Tesla here. So now after this, you have to find your F equals to M A. Never forget that this is what? UOI. So now looking into this, F equals to MA. You're giving your F to be BVQ. This will now be equals to MA. You divide both sides by what? About magnetic field of a solenoid. A solenoid is a long helical coil of wire through which current is run in order to create magnetic field. When you say it's helical, when something is helical, it's somehow like this, helical in shape, as you can see here. So now this is called a solenoid. It's used to create magnetic field in which current runs through it, as you can see here, from the north pole to the south pole. And then you have to take notice of something here. As you can see, the current is flowing from the north to the what? South, outwardly, as you can see here. As you can see, from the north to what? To the south in a solenoid. Now looking into your handout, you see by taking a small segment of a solenoid, now you have something like this. Now this actually means that C to D in this solenoid is what? C to D. This one is parallel to the magnetic, as you can see here. Now from C to B, now there is a law in which states that whichever reference square path is outside, it's what? It will be 0. That is, the B, which is the magnetic flux density, it will be 0, or let's say close to 0, whenever it's outside the solenoid. But when it's inside, as you can see here, it will have a value. Now it means that C to D will be 0, D to A will be 0, B to A is completely outside, which will also be 0. C to D will have a value, as you can see here. So if you look into this, taking the integral of the reference square pathway above, as you can see, b to a, which is what, 0. As you can see, c to b is what, is also 0. But d to c will what, have a value, as you can see here. Then a to d will also be what, 0. So now if you look into this very much, the c to d here, can you see it's inside, so it won't be 0. Its value will never be near 0, which will have a what, a value. That's why it has bl. Others are what, 0, because they are either outside or what, halfly inside. Now looking into this, you have your formula to be bdl equals to what, bl, because 0 plus 0, bl plus what, 0, making bl. And then never forget that your b the l equals to what, uoi. So this uoi represents this a, and this bl comes here. Bl equals to what, uoi, and then you divide both sides by what, l, as you can see here. Now never forget the number of turns of a solenoid. The number of turns of a solenoid, b, is given by b equals to u ni over l. That is, you put the n there. Whenever you're given the number of what, solenoid, you'll be given number of turns, I mean, or they can say it in a way of being the number of what, loop. Now n over l is what, n, because this represents the number of turns per what, per meter, that is n over l, which is n. The formula can be written like this or like this. So now b equals to uni over l, or what, uni. Now let's look into this question over here. Now 50 centimeter long solenoid has a diameter 2.0 centimeter. You know, when it has a diameter and you want to calculate your r, you have to what, divide by 2. Now if the solenoid is to produce a magnetic field, that is the b, which is measured in Tesla inside, calculate the current I required to produce the field. If the wire makes 500 loops, that is, your n will be 500. And then if the wire makes 5,000 loops, that is, you have your n in the second question to be what, 5,000. So just apply this formula so you get your answer straight. Now looking into this here, as you can see here, you have your what, bunil over l. All you do is just to apply the what, the number of loop, as you can see here. So you find your current by making I the subject of the formula. So you change whichever of the value you given in centimeter to meter, d, as you can see here. So that's all, because this is not is not really hard to solve. Very simple. Just apply it, then you certainly get your answer. Now looking into this second question over here, there's a small thing about this which has inner radius and outer radius here. Now the inner radius plus the outer radius, then you divide by what, by 2. That will give you your what, main radius. That's what you're gonna use, and your length is what, 2 pi r, as you see here. And you know the number of the length will be n over what, n over l. That is, you're given 1500 tons. Divide this by the l. So afterwards, all you do here is just to make this uni. If it's this you want to use, or you can just use u equals to what, n over li. Wire carrying current, the you have your I to be 3 ampere here. Then when the electron is at a distance, that is, you have your d to be 2.5 centimeter, which is changed to equals to ma. You divide both sides by what? So I believe that if we have calculated your a equals to 8.44 times 10 raised power 14. I don't want to make this video very long by doing all the calculations, but we've already known our value for b to be this, value for v to be 2 times 10 raised power 8. So our q, we all know the value for that also, and our m, we also know the value. So whenever you calculate this, it's going to give you 8.44 times 10 raised power 14. Now moving into force between two currents carrying wire. That is, when you have the two currents carrying wire, as you can see here. Now, looking into this, Ampere discovered by experiment that the current carrying conductor exert a force on each other. So now, that is when you have the attractive and the repulsive force. If the current flows in opposite direction, that's repulsive, as you can see here. This is a repulsive sign. It's flowing in different direction. But if they are flowing in the same direction, as you can see here, it means it's attraction. There's a force of attraction between the conductor A and the conductor B. Now, if you want to write the formula for this, as we all know, the B equals to UOI over 2 pi r. Now, talking about 2, to know the force in between them, it will be F equals to UOI1, that is the current flowing in 1 multiplied by the current flowing in 2 over 2 pi r. Here, this force is force per meter length. That is, whenever you are asked to find this, the unit will be what? Newton per meter. As you can see, it's different from from the normal force. This one is Newton per what? Per meter. That's why you have it here as UOI1 I2 over 2 pi r. So you have to know this formula. As you can see, I will shortlist many of the formulas you have to know here in this handout for you. So whichever the calculation you're given, if you can apply one of these to it, the appropriate one, you're going to get your answer. Now, outside the toroid, then it means outside the what? Solenoid. So that means what? 0, because wherever is outside will be what? 0. So that's all for this. Now, talking about the belt and Savart law, all you need here is just the formula, because there's no much explanation here because of the longevity of the video. So now I would just tell you to write all these up, because when you're asked about the BERT formula, which usually come out every year in your small and food assessment and exam, you have to provide them with these. The B is directly proportional to IDL sin theta over R square, while the constant of proportionality for this direct proportional sign is what? UO over what? 4 pi. So here it turns to here, as you can see. Now we also have, when you are asked to calculate the magnetic flux due to a long straight wire, you have to use this 2 pi x. This x means the distance. When you're asked to calculate the magnetic strength or magnetic field strength for center of a narrow coil, you have to use this, where your n is the number of the what? Turns or the loop, I over what? 2r. When you're asked to calculate it along the axis of a coil, that is 2. First is when your n equals to 1, that is the number of loop you have. They will state it that taking your number of loop to be what? 1, that it has only one loop. Now you have to use this formula, uia square over 2 into s square plus what? Plus a square. You have to use this over all into what? Power of 3 over 2. When the n is greater than 1, you have to use this without what? 3 all over 2. That is, when your n is to be, let's say 2, 3, 4, 500, greater than that. So that is along the what? Axis of a coil. All these will be stated in your question. So now you need this formula. I will advise you to write all this down, memorize it, know it if you can, as to pass the assessment or the exam. So if you look more into your handout, you will see all these that I've written there. You see all these that I've written. So looking at this derivation of the formula, they're only deriving the formula here. All you need here to pass is the final formula being given to it. As you can see, I've already mentioned along the axis of the coil, of a narrow coil. So you also have this here. I've already made mention of it. Now looking into this example, you use this. As you can see, due to long straight wire, you use this formula to solve this. If you look into your handouts, you see all this. Now at the center of the what? Circular coil, you use this formula to Ni over what? Over 2r. So now, as you can see, just look into your handouts, because this is very simple. When you know the appropriate formula, being given to the question you are asked. So I think this will be the end of our video. I'll see you in the next class. Never forget, when it's assessment to exam period, search for Danfo Academy. The past questions and all other useful things will be released. Thank you very much. Bye bye.